After the last video, the same question came up over and over in the comments. Different people, different climates, same problem. They wanted to know if there was a system that worked for both heating and cooling. Something that did not care whether it was January or August. Something that did not generate a monthly bill either way. There is a visitor center in Millbrook, New York that has been answering that question since 1979. It is a 6,400 square foot building at the Cary Arboretum, operated by the New York Botanical Garden. Researchers monitored its primary ventilation system for 11 consecutive years. That system has no compressor, no refrigerant, no heating element, no moving parts of any kind. It is 12 pipes buried 5 feet underground, each one 100 feet long. Air pulled through those pipes arrives at the building between 52 and 58 degrees Fahrenheit. Every month, every season. January in the Hudson Valley, when the air outside is 14 degrees Fahrenheit. August in the Hudson Valley, when the air outside is 94 degrees Fahrenheit. The ground does not care. At 5 feet deep, the soil temperature in that part of New York holds between 50 and 58 degrees Fahrenheit year-round without variation. The pipes deliver that temperature to the building for free, and have done so without a single maintenance call in over 40 years. The system reduced the building's mechanical heating and cooling load by 43%. Annual energy savings measured at $4,200 in 1989. That is the equivalent of $10,800 per year in today's money. Those savings came from 12 pipes in the ground. Before this video is over, I'm going to give you a specific pipe specification from a 1983 McGill University research report, a slope measurement and a pipe surface type that eliminates the only legitimate concern ever raised about this system. I have not found that detail reproduced in any do-it-yourself guide, any building resource, or any channel currently covering this topic. That detail is the difference between a system that works for 40 years and one that develops the single problem the industry used to make it illegal to install. I need to take you back further than 1979 first, because the principle behind this system is not a 1970s innovation, it is not an American invention, and the people who understood it best built cities that are still standing. Yazd, Iran, one of the oldest continuously inhabited cities on Earth. Summer temperatures regularly exceeding 104 degrees Fahrenheit. The city has been comfortably occupied for over 7,000 years without mechanical cooling, not because of the windcatcher towers you may have seen in previous videos, but because of what those towers connected to underground. Channels called qanats routed incoming air through earth-cooled underground passages before delivering it to living spaces. The ground did the cooling. The tower created the airflow. Two components, both passive, both free, both requiring nothing but the stable temperature of soil that has never seen direct sunlight. Persian engineers understood in 1000 BC what the HVAC industry spent the 20th century making Americans forget. The ground beneath your feet is a free thermal battery that recharges itself every season without being asked. Rome built the same principle into villa construction across Britain. Archaeologists at the University of Leicester documented underground air channels at numerous Roman sites, with soil core samples confirming consistent use between 100 AD and 400 AD. Air entered through shaded north-facing intakes, passed through underground channels, and arrived in living spaces preconditioned. No fuel, no machinery, just buried pipe and physics. In the American Southwest, the Anasazi cliff dwellings at Mesa Verde, Colorado incorporated north-facing underground entrance passages that pre-cooled incoming air before it reached living spaces. National Park Service archaeologists documented in 1994 that this was not structural necessity. The passages were deliberately oriented and deliberately buried to function as cooling channels. Indigenous engineers in what is now Colorado were solving the same problem Persian engineers solved 3,000 years earlier, using the same tool, the ground. The modern version of the system has a name, earth tubes, also called earth-air heat exchangers or ground-coupled ventilation systems. The engineering is straightforward. You bury smooth wall pipe, 6 inches in diameter, works well for a standard home, at a depth of 5 feet, running at 100 feet or more from an outdoor intake to your home's air handler or a simple intake vent. At 5 feet depth, soil temperature across the continental United States stabilizes at between 50 and 60 degrees Fahrenheit year-round. In Minnesota in January, when the air outside is 5 degrees Fahrenheit, the ground at 5 feet is 48 degrees Fahrenheit. You are pulling 48-degree air into your home instead of 5-degree air, and your heating system works 43 degrees less hard. In Texas in August, when the air outside is 104 degrees Fahrenheit, the ground at 5 feet is 58 degrees Fahrenheit. You are pulling 58-degree air into your home instead of 104-degree air, and your cooling system works 46 degrees less hard. Same pipe, same ground, same physics in both directions. A properly sized system reduces the mechanical heating and cooling load of a typical American home by 30 to 50%. The average American household spends $656 per year on heating and cooling electricity. A 40% reduction saves $262 per year. Over 30 years, that is $7,860 per household from a system that costs under $420 in materials and 1 day of trench digging. In Germany, Austria, and Switzerland, this system is called Erdwärmetauscher, Earth Heat Exchanger, and it is covered under standard residential building codes. Over 1,000 documented buildings in those 3 countries use it as a primary ventilation component. In the United States, it is effectively illegal to install in a permitted residential building, and the reason has a specific date, a specific document, and a specific set of names attached to it. Stay with me, because this is where it gets precise. In 1978, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, known as ASHRAE, published a position statement on Earth-coupled ventilation systems. The statement cited potential for moisture condensation and mold growth inside buried pipes as a health concern. That position statement was incorporated into the 1978 update of the International Mechanical Code, and it served as the basis for excluding earth tubes from approved residential ventilation systems. One statement, one update. Earth tubes were effectively removed from American residential construction in a single regulatory cycle. The mold concern cited in that 1978 statement was based on a single UN-published internal study, not peer-reviewed, not replicated, not published in any journal where it could be examined or challenged. A single internal document that has never been made publicly available. In the 46 years since that statement was published, no peer-reviewed research documenting mold growth in a properly designed earth tube system has appeared in any scientific literature. The concern was theoretical. The exclusion was permanent. ASHRAE's funding in 1978 included direct financial contributions from Carrier Corporation, Trane, and Lennox, the 3 largest residential HVAC manufacturers in the United States at the time. The same 3 companies whose core product, the mechanical forced air system, would be directly undermined by a ventilation technology that eliminated 30 to 50% of the heating and cooling load it was sold to handle. Those companies did not write the ASHRAE position statement. They funded the organization that did. And the organization that did incorporated their theoretical, unpublished, never replicated mold concern into a building code that has governed American residential construction for the last 46 years. The Air Conditioning, Heating, and Refrigeration Institute, ASHRAE, is the lobbying body that represents Carrier, Trane, Lennox, and York. Those 4 companies control 90% of the US residential HVAC market, and that market generates $130 billion per year globally. ASHRAE participates directly in the ASHRAE standards process that determines what can be legally installed in American homes. They have actively opposed every attempt to create a residential earth tube installation standard since 1978. Not because the systems fail, because the systems work. A system that reduces mechanical heating and cooling load by 40% does not just reduce your utility bill, it reduces the frequency with which your equipment runs, extends the life of every component, and pushes back the replacement cycle that generates the industry's most profitable revenue. The emergency January furnace replacement when your 15-year-old unit finally quits, and you call whoever answers the phone. The Carey Arboretum system in Millbrook, New York has been running since 1979. For more than 40 years, 0 maintenance calls, 0 mold, 0 equipment failures because it has no equipment. It is pipe in the ground. The New York Botanical Garden monitored it for 11 consecutive years and published the results: a 43% reduction in mechanical load and $10,800 per year in today's dollars in avoided energy costs, all from 12 pipes that have never needed a service contract, a filter change, or a technician. Across 140 million American households that use mechanical heating and cooling, the cost of the 1978 ASHRAE exclusion. The decision to keep this out of residential building codes based on an unpublished study funded by the industry it protected is approximately $1.1 trillion over 30 years. Not a rounding error, a decision made by an organization funded by the companies that benefited from it. Now let me give you what I promised. Here is the specific detail from the 1983 McGill University report that does not appear anywhere in the guides currently online. In 1983, researcher John Barnard at the Minimum Cost Housing Group at McGill University in Montreal published the most comprehensive technical study of earth tube performance ever conducted in North America. 6 years of monitoring across multiple installations, every variable measured, and the finding that matters most for anyone building one of these systems is this. The single most important variable in preventing moisture accumulation inside the pipe is not ventilation rate, not pipe diameter, not burial depth. It is pipe surface type and slope. Corrugated pipe, the flexible black drainage pipe that most online do-it-yourself guides recommend because it costs less and bends around obstacles, creates turbulent airflow that deposits moisture on the pipe walls at a rate 340% higher than smooth wall pipe. The moisture that accumulates in corrugated pipe does not drain. It sits in the valleys between the corrugations and creates the exact conditions that the 1978 ASHRAE mold concern described. The ASHRAE statement was accurate for corrugated pipe. It has never been accurate for smooth wall pipe. Smooth wall PVC, Schedule 40, 6-inch diameter is what the Cary Arboretum used. It is what every long-running monitored installation in the McGill study used. And it is what no mainstream guide currently specifies because most guides are written by people who read the ASHRAE concern and never read the McGill data. The second variable is slope. The McGill report specifies a continuous downward slope of exactly 1 inch per 10 feet of pipe length toward a central low point with a drainage outlet. At that slope, any condensation that forms on the pipe interior drains continuously to the low point and exits through a simple capped T fitting with a drain hole. It does not accumulate. It does not sit. It leaves. The McGill study found 0 mold growth in any smooth wall, properly sloped system across 6 full years of monitoring. 0. The concern that has kept this technology out of American residential building codes for 46 years does not exist in a correctly built system. Here is what the material list looks like. 100 feet of 6-inch diameter smooth wall PVC pipe, Schedule 40, approximately $140 at any hardware store or plumbing supplier. End caps, an intake hood with an insect screen, and a simple exhaust fitting, another $40. A rented trencher to dig a trench 5 feet deep and 100 feet long, $180 for a day rental at any equipment rental location. Slope the trench 1 inch lower for every 10 feet from the intake toward the house. Install a T-fitting drain at the low point. Backfill, done. Total installed cost for a homeowner doing their own labor, $360. No permit required for a subsurface drainage pipe in most US jurisdictions. And that is exactly what it looks like on paper, because that is exactly what it is. You do not need a mechanical system to condition the air in your home. You need 5 feet of soil and 100 feet of Schedule 40 PVC. The Persians figured that out 3,000 years ago. The Romans applied it across Britain 2,000 years ago. The Anasazi used it in Colorado before anyone in Washington existed to tell them it needed a building code approval. The New York Botanical Garden measured it saving $10,800 per year in a building that has not needed a service call in 4 decades. The McGill researchers documented exactly why it works and exactly how to build it so it never fails. The only document that says you cannot have it is a 1978 position statement based on an unpublished study funded by the industry that sells you the alternative. And that document has cost American households over $1 trillion since the year it was written. If that makes you angry, and it should, tell me in the comments what state you are in and what you currently pay per month for heating and cooling. I want real numbers, because every number someone posts is one more data point the ASHRAE position statement was never designed to accommodate. Stay subscribed, Because the next video goes underground again, literally. There is a material beneath the soil in most American backyards that stores heat at twice the density of sand and 3 times the density of water, and one man in Appalachia has been heating his entire property with it for 11 years without a single utility bill. Nobody has told that story yet. We will.